In this video, we're going to go over how to take the square roots of whole numbers that are not perfect squares. What do I mean by that? Well, recall from earlier videos, and you can watch those earlier videos either in Algebra 1 or Pre-Algebra, of how to take square roots of nice numbers, that when you take the square root of something like 16, we know that we're really saying what number squared gives us 16. What positive number squared gives us 16? And since 4 squared gives you 16, we know that the square root of 16 is equal to 4. So if you're not well educated or brought up to speed on how to take square roots of nice numbers, check out my earlier videos in Algebra 1 or the Pre-Algebra course of how to take square roots of perfect squares. Now recall too that any number inside the square root sign is called the radicand. Right? So 16 is the radicand. Oh, it's a big number. And then this symbol right here is the radical symbol. So the whole thing is the radical. So square root of 16 is a radical. Like, whoa, radical. But the question becomes, how do I take the square root of something like 8? Where you're thinking, what number when multiplied by itself gives me 8? Well, no number does nicely, no whole number, and that's because if you think about it, 1 squared is 1, 2 squared is 4, and when we get to 3 squared, we've surpassed 8. So it's going to be a number close to 3, but not exactly 3, because 3 squared is 9 and 2 squared is 4. So how do we at least simplify that? What you do is you look for the highest perfect square that goes into this evenly. So I'm going over the why behind all of this, and I'll introduce you to it. In a later video, we'll do more practice of it. So what is the biggest number that is a perfect square? These are your perfect squares. We could keep going. 4 squared is 16. 5 squared is 25. To generate your perfect squares, just square the whole numbers. 6 squared is 36. 7 squared is 49, and you could keep going on and on and on for a very long time. 8 squared is 64. We'll go up to 10 squared. 9 squared is 81. 10 squared is 100. Okay, so we're looking at this. What's the biggest of these numbers that goes into 8? 4. So what I can do is I can rewrite the square root of 8 as the square root of 4 times 2. Okay, and that can be rewritten as the square root of 4 times the square root of 2. Anything that's underneath the same radical like this can be split up into 2 separate radicals. It equals back up to the square root of 8. Well, here's the cool part. We know the square root of 4, it's 2 because 2 squared is 4. So we would get 2 times the square root of 2, which we write as 2 root 2. And you might say, okay, I guess, but what does 2 root 2 mean? Well, the square root of 2 is an exact number. As a decimal, it's approximately 1.4 and change. So this is about 2.8 if you multiply it out as a decimal, about. But just like with pi, where that's an exact number and 3.14 is its approximate, this is the exact value, the approximate would be with the decimal. So this is read 2 root 2, or 2 times the square root of 2. How do you check to make sure that's our answer? Well, we check that 4 is our answer by multiplying it by itself, and we get 16. So the check would be, I'll multiply 2 times root 2 by itself, which would be times 2 times root 2. Well, 2 times 2 is 4. The square root of 2 times the square root of 2 is the square root of 4, which is 2. And that gives us 8 back. So indeed, when I square this or multiply it by itself, I get 8. So it's the correct answer. You don't have to check every answer, but I wanted to show it to you at least once. Then you multiply your answer by itself to check with the square root for the same reason as I showed you there. Okay, we'll do one more. So we've got the square root of 12. For the square root of 12, we need the biggest perfect square that goes into 12. Well, again, that's going to be 4. Okay, so we could rewrite this as the square root of 4 times the square root of 3. I skipped this step here and went right to that step. Well, the square root of 4 is 2 because 2 squared is 4 times the square root of 3. So our answer is 2 root 3. Awesome. You know what? I'll do one more just so you don't think the square root of 4 goes into everything. Let's do the square root of, I don't know, let's go with 70. Let's go with 50. That's not a bad one. So the square root of 50. Out of all these perfect squares, what is the largest perfect square that goes into 50? And the reason why I picked the largest is it greatly reduces the amount of time we spent. So the largest perfect square is 25. So this would be the square root of 25 times the square root of 2. Because 25 times 2 gives us 50, we know we're on a good track. What number when multiplied by itself gives us 25? 5 times the square root of 2. There you have it. So that's a little bit of know-how of a technique of how to simplify square roots that aren't perfect squares. You look for the largest perfect square that goes into them, you take that factor out and simplify it down. In another video, I'm going to show you an alternative method that you might have been taught in class, just to explain it so you understand it. That's using factor trees. To be clear, this is the method that I prefer. See you soon.